He calls it structures, and some of the terms you've seen some of these equivalents in Python. Some of the term Professor Zhao refers to as the data structures. I refer to as the composites. But now you're looking at the Java equivalent. Now, an example of a data structure, as Professor Zhao called it, I call it composite, is the list. And I called it a composite because unlike the primitive types, a integer, a Boolean, you can't decompose the numbers in an integer with the built-in operations and still have it make sense. You can't extract the largest digit, the slowest digit. It's atomic, I'd call it. But composite can be decomposed into parts. You can access individual parts of a list. Okay. So a list, you may or may not be told in 231 that with lists, the nearest implementation in most languages is an array. It's not a perfect match, but the key operations of a list you could implement in an array. Everybody else calls it an array pretty much. We don't decide to call it list for some reason. And there's some other ones as well too. However, data structures isn't what this course is about. There is a course, a aforementioned course, when I talk about algorithm efficiency, nested loops, data structures and algorithm, this course. That's where you'll get into great detail. Some of you might have seen an introduction in data structures, trees. So it's like a list. Basically, we go one way, essentially, connection between the elements, a 1D list. A tree allows for forking. That's the basic idea of the fork. And we can have 2 or more forks. So we have a tree where we have directory structure. A folder contains subfolders, and it can contain 0 folders or multiple folders. But we will cover some data structures, but the next course essentially is a major part of it. And if you have looked at Professor Hudson's notes, his outline, there's a buffers topic I keep referring to. It's probably going to fall off the table. It's data structures because it's not in the required curriculum for this course, and it's in another course. But there are some of these composites we talk about. So list, no direct translation. We don't made a unique type here. However, the nearest equivalent I indicated for the main operations is an array. An array is a type of variable, lowercase. You have seen some created. You can't declare a variable that is of type array. So you can declare a number like this, but you can't say my variable is an array type. Of course, the syntax isn't right. Because an array, actually it's called arrays, is something entirely different. Array list is something different. It's a class, and you should be able to follow the standard. The first letter is capitalized. This is not capitalized. This is a type of variable, but not a class. This is a class, and you can create objects potentially if it's non-static. Okay, let's look at these ones. The array out of all these composites across languages, I tend to find this from usage is the most useful. You spend most time on it. It's the most common need for it. So contrasting the differences between some of the major things between a Python list and a Java array. Heterogeneous, you might have seen in some examples. You can do it if you want to. The elements can be of different types. You have one element that is an object reference, one element that's a string, one element that is a Boolean. Mix and match however you want. I said if you've seen some, personally I showed some in 231 just so you could do it, but there wasn't really a great need for it in most cases. Homogeneous arrays pretty universally, each element has to be same type. So when you actually declare array, recall, this mentioned, sort of reminder, you have to specify the type, and that indicates that it's not a single string, but an array of strings. And you cannot change this. It's not necessarily as constraining as it seems. Well, if we talk about inheritance, I'm really hoping we are. It's not explicitly listed, but in Professor Hudson's topic list. But then sometimes he names things in a different fashion than I'd imagine. If we talk about inheritance, that's where you can have briefly. You've seen inheritance in the parent class, child class, but actually getting into the nuts and bolts. If you have inheritance in classes and objects, one class inherits from another, then the homogeneous requirement isn't as constraining as it seems. At first, it seems like this really sucks, but it's not as bad as it seems. And it's homogeneous because it's a strongly typed language. You don't want to mix and match. Similarity, you access from an index. Because the index starts at 0, it's a size -1. Or quickly thinking about it, if we have an array of one element, it's index 0, not index 1. Its size is 1, but the index is size -1. If both languages are quite nice, Python and Java, you get a runtime error rather than logic error. So if you exceed what they define as beyond the bounds of the list, if you go try and access index size, not size -1. So with the array with one element, trying to access non-existent index 1 in either one, you get a runtime error rather than a logic error. However, I had said that even though Python lets you do things you shouldn't get in the habit, negative indices, it's a handy shortcut for accessing near the end of the list, but I knew it could give you problems if you got in the habit of using this when you learn other languages, because you're still beginners. No negative index, and if you have a negative index, it treats as exceeding the bounds of the list. Python's kind of unique with a negative index. One thing that you might really miss at first is dynamic. Consider the append method. You can have an empty list and then dynamically create it, add on elements. However, it could be a user-defined number of elements at runtime based on a variable. The size is fixed. Recall when you actually create an array in Java, now I'm actually creating an array. I have to put in a value. It can be a named constant, unnamed constant, but I can't grow it after that. What if I say have an array, existing size, and I want to make it bigger? Well, what I could do is I create another array 1 here, just to distinguish these two, smaller. Might do a fair amount of typing in this case. Leave this default. And say it needs something that's double in size. Language independent. Like in a language such as C, you don't have a lot of functions associated with arrays. What would you do to make a bigger one and then manually copy element by element? It's not really all that hard. It's a little bit of work for beginners, but it's not a bad thing because doing this manually, because it gives you practice working with things. And then if you screw up, that's a real pain trying to debug it, but it's actually a good thing because you're more likely to learn. So it doesn't have the ability to dynamically resize the array itself. Some of the array classes do. The Python list, well, everything is a class. In this case, you have many, many methods. And here's a quick summary, the Python org documentation. The array, I've stressed, the array type is not a class, so there's no methods. An integer primitive atomic type is not a class, lowercase integer, so you can't call methods on it. However, the array type does have an attribute length, which is as you think it is. It stores, it's a variable that's attached to each array that stores the size of the array, and you can use it for traversing the array, as you'll see. However, if you have need for methods as a professional programmer now, that's when you graduate and you start working in the field in industry, you have learned the basics. And during the vetting process, the interview process, they've determined on top of your degree that you have a level of competency. So you don't, in general, basic things you don't need to practice. So you can and almost certainly will be using methods. If you have one for some of these methods, if it's to save time, you'll probably use a method rather than writing it itself once you know what you're doing. You can use the arrays class, plural and capitalized. For instance, displaying the contents of an array. You can call a method of arrays and call the toString method. Right now, as is, unlike with a Python list where you can pass it to the print function, you can't pass an array or reference to array in Java to print in println and get the array contents displayed. But you can display it, as you'll see, through one of the methods of class arrays. Some of the operations, so operations are different from methods. Use an operator concatenation for strings, for instance. That plus sign is not a method. There are many operators for Python lists, not just slicing, but that's one. I believe repetition, just like with strings, the star. Slicing is not available, but other classes can provide this capability if you need it. Or you could write your own code. Say existing array, if you have existing array from index here to index here, copy the elements and have those copied to a new array. So it's possible, even without using other methods. Now, I've hinted at this, you can't just pass an array to print in println, but you can use the array's toString method, so I'm putting this in writing, display the contents. So if we have an integer array here, if we want to actually have the elements displayed, then we can pass it to toString. With this toString method, is it static or non-static? Hand for someone, raise your hand if you can answer that one. A hint, the class name is arrays, so this is the class name. That's a big hint. Is this static or non-static? It's static because we call static methods through the class name. If you tried to instantiate it and call this static method, it would give you problems. You cannot call a static method through reference typically. So that's why I had some of those questions in the last quiz, having you recognize and pound home the difference between static and non-static as you're actually using pre-created methods and writing your own, frankly. So there are many properties of arrays, but here are some of the common ones, the most important ones to keep in mind. Specify the type, square brackets goes from 0 to size or number of elements minus 1. They're homogeneous, all the same type. It has a length attribute, and it's fixed in size. How to create an array? Formally, the syntax. I had to show examples, kind of hand-wavy about details. We specify the type. We specify with square brackets that's an array. The name of the array. The new keywords are required because it's allocating memory on the heap. And this part and this part should match the type of each element. And then the max, that's the number of elements. And we can use named or unnamed constants. There's advantage using named constants. We'll see. An alternative way of creating an array, this is less common, where we use, this is I believe C, but definitely a Java thing, where we indicate that it's an array here with the square brackets, but we can initialize it right here with the curly braces. That's the main advantage. Same way we can actually hard code the initialization of Python list. Or we can also do it this way. So this is indicating that it is an array, but we need the curly braces to actually specify the elements. We can't just, and I tried this to test it, get rid of the curly braces and stick this inside the square brackets. What it is looking for inside the square brackets is the number of elements, not the value of the elements. So the way to specify it is with the curly braces. That's the use of it, if we're hard coding it. So this example, 1D arrays for time. What do you mark? Yeah. If there's any questions at this point, catching up to the other lecture. Okay, so with this example, a bit of time here, I might actually pull this up. Oh, I shut down IntelliJ. And I'll just pull it up code-wise because there's some stuff that I have. I say a complete example, I just include the relevant learning objectives, examples, and structures. Is this the one that has... Yeah, this is the one with the grading, so I'm going to pull up this one and not the next one first. So we're importing a class. The Java utility library, it's actually called a package of classes, includes many useful things, including some of the list types, like array list. It also includes class random. Class random, as the name implies, allows you to generate random numbers. Random numbers, it's not part of curriculum, but it's just such a useful thing. When would you use it? For simulations. Say we simulate probabilities. What's the probability for doing traffic simulation of a weather event? And then a weather event, if it occurs, then we can have it go into simulation and affect traffic, like snow events or something, or heavy rain. Or it's also used for games, probabilities for games, RPGs, driving simulations, and so on. I use it here just to populate the array so I have different values. That'll be used in conjunction with max grades. But in order to actually use the random library, to actually create a random object, I need to import the random class name. So I'm going to have an array, max students. Each student grade is stored in an array, and the maximum number is 10 here. Now the grades in this example are going to be percentages, so the maximum percentage is 100. Fine. And I'm going to, let me look at this here for a sec. And I'm going to traverse the array twice here, both of a for loop. I feel I could use a while loop. These are basically the same thing, except for the condition, stopping condition here and here, how I specify it. Now, max students, recall, is a name constant 10. That's number of array elements. Max students immediately is used here because it determines the size of the array. And it also determines this is going to go from 0 to less than max students is 10. In other words, from 0 to 9. If my class capacity suddenly increases from 10 to 100, well, it's going to increase the size of the array immediately, automatically. And then also, this loop is going to traverse automatically from 0 to 99. So this approach here, where I use a name constant in conjunction with the creation of lists, it's language independent. If I don't have any methods for determining a length, and I don't have a length attribute, I'm just showing you this technique because I'm not trying to focus on the specifics of just the language. C, for instance, and Pascal are ones where you should do something like this. Why am I using a name constant? Why don't I use an unnamed constant? I did have an unnamed constant in the example I put up. That's to get you started. The problem with an unnamed constant is this. If I change the size and I refer to the size of that array many times, then I have to remember to change each and every one of these 10s. In a small program, it's only 2, but in a real life program, it could be any times. If I miss some of them, then I've got a logic error. If I change ones I shouldn't, then I've got a logic error again, or perhaps a runtime error. So by using named constants is good style, and this is why other languages employ this. It's good style, but also reduces the likelihood of logic or runtime errors. So this is a language independent approach for creating an array and traversing it based on a named constant. And this loop here is going to step through the array grades, index 0, and put a value here. And this part I'll talk about in a minute. Then it increases I from 0 to 1. And now at index 1, it's going to put a value. And keep going until it goes up to 1 less than max students. Max students is 10, up to the index 9. Fine. Now, what does this do? This is just so we have variation. So I don't give each student the same grade. And so I don't have to prompt the user, have something that slows down the program. It randomly determines a grade. A random number object, there's a number of methods. Next int will basically generate from 0 to the integer that you pass into it, but exclude it, 0 to less than the integer. So max grade is 100. So this is going to generate a grade from 0 to 100, 0 to 99, less than the 100. If I want the range, I want the range from 1 to 100, then I add 1. 0 plus 1 is 1. So that's the minimum value. The maximum will generate is 99. 99 plus 1 is 100. So it ends up generating a grade from 1 to 100. And quickly looking at different runs of the program, see the scores different. Just so I had different grades. And I suppose a little bit of humor. Sometimes students kid around. Grading is just randomly determined. Profs with exams, they don't do this. Now, another way of traversing arrays, this is Java specific, taking advantage of a length attribute. And the length attribute is what you think it is. We've created, let's see where, we create an array here based on max students. It's 10. The length attribute is going to be 10, length of 10. And it's going to go from 0 to less than 10. In other words, from index 0 to index 9, and it's going to display the grade. Two ways of traversing it. Use either one, but I've introduced this one because it's language independent. There's no style problems. This is the Java specific approach, maybe a little more elegant this one, but you should be aware of this approach. Now, when I actually display it, I indicated that you cannot just pass an array to print or println, the printing functions, and expect to be able to see the contents. What I did was, in this case, I'm traversing one element at a time based on the I value, index I0, and then I display the grade. I pass that grade, and it's going to be an integer value to print. Then this increases to index 1, and index 1 happened to have 14. If I tried to pass an array, not the other types, but an array to print or println, I said you get a number, a letter, the @ sign, and then some numeric value. People who are beginners, or even some intermediate people, will then think that's an address in memory. And it's not necessarily a bad assumption, because you think about it, from what you've been told and how it actually works is, when we create the array, we put the address here. And what we're passing here is the contents of the location called grade. So intuitively, we're displaying an address in RAM. Well, addresses are specified in hexadecimal, and hexadecimal, so why this is not an address, goes, if you recall, from A to F, that's I. So it can't be a hexadecimal value. If you actually know where to look in the Java API for this, it's actually a toString method of class object. It says that toString method, which automatically gets called here, displays a hash code value. And you learned a little bit about hashing with the dictionaries in 231. You have some key, unique key for a value in a composite, and you look up values in that dictionary based on the key. But the hashing is the mapping of the key to the value, not the key itself. So I didn't say something quite wrong. You can think of it as almost like a serial number, a unique identifier for a reference. So the Java runtime environment that's running your programs can identify one object from another. But that's not useful in most cases. So one way of displaying array elements is for a 1D array or 2D array, we'd have to pass the row column for 2D, 1D array, just passing the index. Any questions at this point? No. Now I do have inside of D2L a very basic 2D array example. I also emailed you to indicate this. It implemented as simple as possible. I think it was called class as simple as possible. And it showed how to create, with a 2D array, how to create one, and then how to display values. And as you created it, it showed you how to access and assign values to the array. But I also said that you should have been able to extrapolate some of this based on what you've been taught about how to declare an array, create an array, and then essentially you can see this is very, except for this part and this part, this is basically the same as in Python. I also sent the documentation for that example for people when I looked at it, that I was trying to keep it simple, so I didn't employ good style, such as either using the length attribute or name constant, because I was really trying to keep it extremely simple. Two things I'll poll in a moment here. Anyone look at that example in this class? You did that 2D array example that I put in D2L in the folder for this week. Okay, I'll ask no hands so far. Okay, that's okay. Someone didn't need it. It's there if you need it. The second question I'll then ask is, I hope you've at least started. Has anyone had trouble implementing in the assignment or tracing through the code that Professor Hudson has, starting code, in conjunction with 2D arrays? Any issues with that? Raise your hand. They didn't say any issues in the other class either. And some people had started. Hopefully there's no issues because you understand it well enough, as opposed to you haven't started it. But in terms of technical requirements, Wednesday, I think I covered the last little bit of, well, even before Wednesday, when I talked about static, maybe about Monday or so, is when you had enough technical information to be able to start implementing the assignment. So do start working on it as soon as possible. It's coming up due soon. Now, the additional parts of the structures I talk about aren't necessary for the basic beginning of the assignment. They could be useful, or they could be used for more advanced parts. But you have had the ability to start the first assignment at the very least. 2D arrays in greater detail. So I have name constants, you can see where it's leading, for traversing the array. Max rows and max columns are variable. I'll use that Java approach for determining the length with that length attribute. So I'm going to traverse it two ways, one with this, one with this. And I'm going to, this is a reference to a board, 2D surface, indicating that it's a 2D array, 2 square brackets. And I create it here. This is where the name constants come into play. So it's going to be 4 by 6. It is not a square, but a rectangle. Not a square, so I purposely made it different size. But arrays in languages I've seen, Java included, the length of the rows, the width of the rows are all the same. So it is a rectangle, as opposed to some odd shape where it's staggered number of rows. That's something to keep in mind. The number of columns in a row, it's going to be 6. It's consistent. So with a 2D array, I show the two approaches one more time. One with the name constants, this is going to go from 0 to less than 4 because we have 4 rows. This one's going to go from 0 to less than 6 because we have 6 columns here. Just showing you how to use with name constants traversing an array, a 2D array difference. And now we want to assign values to be able to access an element, just like with Python. The square brackets, first one indicates a row index, second one indicates a column index. Checking my time here. And I'm keeping this one simple. I just assign the current row value. So row is 0. Everything on row 0 is going to be set to 0. And we traverse along that row from column 0 to column less than 6. The next row, R is 1. We go from column 0 to column 5, and each value is 1. Fine. The second approach for iteration. So I'm doing initialization again. I trash it. I normally wouldn't initialize it here, but I'm just showing you how we can traverse it the two different ways. So this was with name constants. Oh, I screwed up. I should have used max rows here. Class drat. Fix these here. Drat. Learning objective. Put these in bold and I'll upload this small thing here, the fixed version. Oops, max columns, not max rows. Copy paste there. So I'm not going to traverse it based on the name constants here. Instead, I use these variables. I declared name constants here to create the size. Then I have 2 variables. And I'm going to use these variables in conjunction with length. So second approach is, when I'm passing an array, a 1D array, when I actually access the length attribute for 1D array, it's simple. It's a number of elements. But if I have a multi-D array, 2 dimensions or more, what do I get? Well, think of it this way. Looking for something rectangular here. Something rectangular. A 2D array basically consists of 1D array. Each row is like a 1D array. If I access the length attribute of a 2D array, a board, then what I'm going to get is a number of rows, as you can tell by this name here. If I want to get the number of columns, I only have to do it once because it's rectangular. Number of columns is the same for each row. Then any row, I can access the length. I get the length of one particular row. So if it's a 2D array, then I get the number of rows if I just access the length attribute. To get the number of columns, then I need to access the length attribute of any row. Now that I have the number of rows in max rows, number of columns, then I use it to traverse the list here rather than a name constant. And the R values are going to go from 0 to, what is it, less than 4. C values from 0 to less than 6. The rest of it's the same except for this part here inside the loops. And it's just showing the other approach. This is a Java style approach, which you use in class. I don't think he's going to prohibit this stylistically in the marking key. You can use either one. If you really want to be safe, then use this one. In case you get a finicky DA saying, this is bad style, and then you have to contest it. But you should be familiar with this approach, even if you don't use it in assignments. Okay, so with a 1D array, I said you cannot pass that reference to the array to print or print ln. With a 2D array, the same thing holds. So I pass a board, it's a reference 2D array, I get a hash code, and we have the square brackets indicating it's 2D, 2 square brackets. Now, with toString, I believe I carefully said this in the morning lecture. I believe I said this in this afternoon lecture, that the arrays class toString method can take as an argument a 1D array. If you try and pass the whole 2D array, this whole rectangle to toString, you're going to get a hash code again. Actually, the hash codes, 1, 2, 3, 4, of each row. So what you need to do is, I'll jump to this one, display each one with toString, arrays toString, and we pass to it. We traverse the rows from 0 to less than 4. Now, it doesn't display it nice. It displays that Python way. So it has the square brackets indicate that this is essentially each row is a 1D array. But this is useful enough for debugging. In the Connect 4 game, or the variant that you're implementing, if you have bugs in your program, you almost certainly will. The first thing to double check is that your data is correct. Display the board. Because if your data is correct, then your rules are irrelevant at that point. So that's why I suggest when you have bugs and apparently it's not running properly. If the data is correct as you expected at that point in the game, then the next thing for debugging is then to check your rules as you're actually adding in pieces. And this is a quick and easy way of seeing the state of the board. It's not what you show to the player with a text-based output, but it's useful in an internal debugging message. Now, to display it nicely, what we have to do is traverse along the rows, row 0, and then we traverse one row at a time, row 0, and then along that row from 0 to less than columns, all the elements. We pass each element, and now each element, in this case, can be passed to print. Right here, because each element is an integer, which can be passed to print. So we display it on existing line print, not print ln, because we want all the elements on the same line. And until we hit the end of the row, the last column value, then we actually move it on, display in the next line. And recall that when I initialize it, everything on the first index 0 is 0. Everything index 1 is 1. Kept it simple. Any questions about the 2D arrays? So this is a more complex form slightly than I have of that very basic example that I uploaded into, week 4 in D2L, that module. That module where you have a link to notes and link to the lecture video. But you can see almost all of it is, for these basics, is identical to Python. It's basically just the creation of the array that's different, and perhaps when you iterate through it, how do we do it? It doesn't have a method, a length function that you can pass lists to and strings to, but we have a length attribute. Array of objects. I put quote objects because most of the time when you have something like this, you can think of Jim as an object, but there are times that you have to know that it's a reference to an object. So over here, I'm going to run out of time here. You have to know it's a reference to an object because I haven't created a person object. Here's where you create. This is right now null. This is where you create an object, put the address here. With arrays, this part people don't have trouble with. I haven't created an array yet. This is null. Now I create the array, I put the address here. But with an array of objects, each element is not an object, but just like Jim here, it's a reference to an object. So I need the first step. Person, this is an array of references to person. And then, okay, then this is null reference to the array. Then I create the array itself. But what is each array? Each array is equivalent to that. It's null. So if I try and access the elements at this point, I'm going to get null pointer, similar to how I get null pointer here. And checking clock amount of time here. So when you have an array of code objects, you actually have an array of references. With an array of primitives, you have to actually create the array, but each element is a primitive. No problem, you're done. Keep in mind when you actually have references, there's 2 steps involved. People coming in the room. With a regular reference, it's 1 step. With an array of references, it's 2 steps. This doesn't create an object, as you should know at this point, but we create a reference to an object. This creates the object, puts the address here. Consequently, you should know at this point, this a person, we've set it explicitly null, but if we didn't set it to null, that location is null, so that if we try and call a method on that object, we get null pointer exception because we haven't created an object. We can't call an object's say name method. Oh, should be let's method call brackets here. In a somewhat analogous situation over here, this is a reference, a null reference to an array. Now we've created the array. We're at this step with 3 elements, but each element is null. So each one of these elements is equivalent to this. People don't understand this step, and then they try and actually do something with an object, but the objects don't exist yet. Consequently, we have to create an object for each element, and that's where we didn't get to last day. We have a loop, and with each iteration of the loop, we create an object, put the address in here. So in effect, what we're going to do is we have a person created person object in that loop. And instead of null, we have each element contain the address of person. And that's what we do through each iteration of the loop. And then because we have an object, we can call set age to the value of I. Next time through, we create another object, and then the second array element refers to that object. That's the extra little step you have to do. And with the complete example, it's just a runnable example, but it doesn't show new concepts that I haven't talked about. We have person, class person, has 1 attribute, simple one, but the main thing is it's a class, and we instantiate objects. We're going to have references to an object. Oh, yeah. So the null reference to the array, we create the array, 3 elements, and then we step through in a loop and actually get the values. Displaying the values isn't hugely significant. So running a program, the screen grab sufficient. We create the object, put the address in the corresponding array element. Then if that array element, we can set the age to the current I value from 0 to 2. And then once we've created the object, set the age, and we get the age. But the key part, really the key learning objective, it's actually right. 2 things. This part is key, but most people don't have trouble with this step right here. The second step, going through the array of references, not actually objects, that's why I put code objects, is the part that people miss, and then they get null pointer exceptions because they don't understand how things work. Removing elements. This is a matter of semantics. What does remove mean? Remove, most people think of remove as it's physically removed from that collective. If I was removing someone from the class, the demo in class, just for humor, I physically say, get out, that person leaves. That's when they're removed. I don't stick a flag on their head saying you're removed. Well, this is where it's semantics. So with the removal, first off, primitives, you can't do this, remove. In an array, you can't actually change the size, so you can't physically shrink it down. Fine. The objects, well, the array of objects is references, And the way he defines remove is you're not shrinking the size of the array, because if you recall, Java arrays can't grow. They can't change in size once you create them. So they can't grow and they can't shrink, but you just mark it. It's like putting a flag on the guy's head in the class that you kicked out saying you're actually removed. It's semantics, what remove means. With that, if we actually had primitives and there was an invalid value for primitives, say that it was an array of grades, grade points from 0 to 4, then we could mark, for instance, a empty array element by having an invalid value, a negative value, or value beyond 4. So according to that logic where you're marking it as being removed, then we could do it in certain cases here. But in either case, we're not physically changing the size of the array. Since if we mark it, that's his semantics definition for removal, then that's counting as remove. It's just knowing the terminology uses semantics. Okay, the other composite types, these ones will be fairly quick. There are many, many composites in Java. Why these ones are picked, I basically used the same ones that Professor Hudson listed. He picked these ones because he wanted to find as close as possible the Java equivalents to the Python structures that you learned. That's why I explicitly list this. There are other ones as well that are kind of similar too, so just make you aware of that. But presumably, if he quizzes you on this, then these are things he'll quiz you on. These, I said in 231, maybe your prof in 231 also said this. Out of all the composites that we talked about in 231, things like a tuple, an array, or a list, and so on, I had said, and the other guys might have said, that the list essentially, from experience, from observation, or list equivalent, which is roughly the array in Java and C, is the most commonly used one. Bearing that out, notice that with the arrays that I've created in the example, if you look at where's my, say if this example here, if you go through the actual code, there's no import of array. There's no need to import an integer, no need to import an array, because it's so used so frequently that it's a core part of the built-in language. But then I added in 231 that other things like dictionaries and tuples, well, they're nice for certain categories of problem. They're very, very useful, but they're rare categories of problem. In a similar fashion, arrays in Java are built in, but these other types over here, the additional functionality beyond basic arrays, you actually have to import them. And they're imported from the library. The actual Java term is a package. So this is the utility package, util package, because they're not as commonly used. So it kind of bears out what I told my people in 231. The array or list is the most common. And in order to actually instantiate one of these instances, you have to import the name so it's aware of, well, what is an array list? It's defined here. Okay, sums interpretation. It's the closest implementation to Python lists. And I'm not going to go and maximize those because I ran into some problems here. Essentially, it skips slides. I'm going to have to go back. I noticed on the weekend some things were skipped in the either intro to OO or the procedural programming. So go back when I've actually caught up. That's a PowerPoint thing. Okay, back to this. So there's a list, actually, a list in Java. If you look this up, it said, well, this is the closest implementation, but it's, if you look at the fine print, it's actually not a class. A list in Java is what's called an interface. An interface is kind of similar to a class. You'll see apparent methods, but it's not identical. I hope that in the curriculum there'll be some time to talk about interfaces versus classes, because it's, or the equivalent. The equivalent of it, it's called the interface in Java. In C++, it's an abstract class. It's a very good design tool. The bottom line right now is an interface is like a class, and you have method names, you have return types for methods, you have parameters, but the one small but key difference is there's no bodies for any of the methods, not even empty bodies. Now, it looks very strange having interfaces defined like that, but there's actually a purpose for doing that. But given some time, hopefully we'll be able to talk about that. But because there's no methods, no method bodies at all, you cannot instantiate an interface. You can't call methods because there's nothing to run. In case you say, well, I'm wrong. You're correct in that there's a list, but it's not a class. So the array list is different from the Java array list, different from Java arrays, where it includes includes methods. The Java array is a type of variable like an integer. It doesn't have methods. And it's an exception where it actually has an attribute length. The array list is an actual class, and classes have methods, which include things that you can tell what they do from the name. So it's actually stylistically, these classes are actually defined fairly well in that they're self-explanatory, looking at the method names and a brief description. The array list is like a Python. I wonder when they add the array list, I didn't trace through the history, but I wonder if Python influenced it where they have an array that increased in size, because there's something that's coming up where they added to Java that they borrowed from C++ with the angled brackets. I wonder if they borrowed this from Python. That's an aside. Slicing, there's no operator, the square brackets, where you have start index and index, but there's a method called sublist that acts like slicing, so you won't miss it. It returns, well, there's that list interface, but an array list is a type of list, so that's actually okay. So if you have an array list returned from the sublist, well, that is a type of list. In a way, it's almost like a teacher is a more specific form of a person. A police officer is a more specific form of a person. Is a police officer a person? Yes. Is a teacher a person? So is an array list a list? Yes, it is. It's a more specific type. The other quirk about this, I don't know why I did it, but something Professor Hudson pointed out, is that unlike a Java array, which can contain primitives, contain references to objects, the array list is constrained only to references to objects. So some code and a table that summarizes some of the methods that Professor Hudson thought was important. So we're creating, except for the angled brackets, this is something I've alluded to. They borrowed almost certainly from C++. We'll leave out the angled brackets for now. Oops. If you see this, capitalized, it's a class. This, it's an instance of that class, or actually more specifically, a reference. So you've seen something like this before with, say, scanner as an example. Adding in this, well, an array list is a composite and it breaks down into individual elements. This is where we can say each element must be a string. We specify a class name here. They borrowed this almost certainly from C++. I remember as a student, I saw this in the C++ templates. So now that we say it can only contain strings, when we actually create the array, we need the angle brackets here to indicate that it's an array list with references to strings. But each element, there ain't no elements. It's size 0. So unlike an array, we don't create a fixed size, but we create an empty one, then we can add to it with the add method. Now the add method, use it sensibly. I mean, okay, right now we have no elements, so we're going to add an index 0. Someone might say, preempt this question, what if we add it at this point to index 20? It's not a good idea to do it because we don't have index 1 to 0 to 19. We can get some unpredictable results. So think of it this way, is if we have no elements, don't add it beyond the bounds, because you can look at the API and see if they have an explanation for what happens. And then to get an accessor method, be able to get that element, display the array element, which is that string. Now this part, what if we actually call set and then we specify an existing index? This is a valid question. Update, or we override it. So at index 0, it's called modified. You'll see modified. And we can also get index, put it into a temporary and display the temporary, just so you're aware that this is a possibility, or we can do it all in one step as we did here. Remove. Now this remove is unlike the array, where the array, when we mark it for removal, it's still there. It's still the same size. This remove actually physically removes it from the array list. And the array list, if I recall, in the back end, how it actually stores it is an array, but it resizes it for you dynamically, if I recall the API. So this remove actually gets rid of the array. And now we print the size, it's going to show 0. If we try and do something, it's like trying to say add to 20 when we've got an empty array list. Well, we're trying to get from 0. It's like trying to get from beyond the bounds of an array. Runtime error. So that, whoops, that does demonstrate here the size being 0, and in this one does demonstrate it's actually physically removed, unlike the array. Okay, the other way, back here, now this makes it a homogeneous array list. Each element has to be a string, homogeneous, all the same type, like a regular Java array. Over here, now it acts kind of like a Python list, where it's non-homogeneous. Elements don't have to be all the same type, so we don't have the angled brackets. So we add an index 0 and 1, a Boolean, and a string just for the heck of it, which is fine, because we didn't specify type. Index 0, we update to there. We get the 0, and we said add the string add 0, and we just retrieve the data, which is that funny looking one on purpose, so you can see that I've actually updated it. Iteration. Now, a standard way of iterating through these composite types is with the for each loop. So because of the composites that Professor Hudson has chosen to cover, the for each is actually has quite a bit of use. So what we can do is, a thought occurred to me in class this morning as I was going through this. Before this, I actually said in the notes for one of these other composites that in order to use a for each, because as we retrieve each element, we have to specify the type, that this only works with a homogeneous, where we specify the type here when we create it, create the variable, and create the actual array list. This would work, but then I started thinking to myself, if it was non-homogeneous, well, the array list can't store simple types. It has to store references to objects. You have learned a little bit the concept of inheritance, where we have a class, certain capabilities, and then with inheritance, we have a child class that gets all the capabilities of the parent class, that's a term here, the first class, and it has its own. In a way, we can have, say, class person that has certain capabilities, and then class teacher that can do more, that does everything that a teacher does and more. Well, with that in mind, in Java, the parent of all classes is class object. So I don't know if this will work in syntax, but if I had a non-homogeneous array list, it just occurred to me, if I actually said that the type was object, because the object is the parent of all Java classes, then everything is an object in Java. So I wonder if that would satisfy the requirement here. You said object element. I haven't tried it with code yet, but I had a thought here if it was non-homogeneous and you wanted to use a for each. With the array list, however, you do have a size tracker, so you can still iterate by the index. Given that you know the size, we go from 0 to size -1, although we don't have this ability with some of the other composites. So that's why I started thinking about this. Now, with the inheritance, the more nuts and bolts of inheritance, I saw it actually comes in development. There's a bit of a jump again. We don't talk about inheritance formally there, but he actually starts having an example of inheritance with the exception handling. So hopefully we formally go back to inheritance, but my mentioning the inheritance here isn't so much a jump, because conceptually you should have at least heard the term inheritance, and I gave you a bit of a review. Now this is a summary table of some of the methods. You can look at the full API to see all of them. I basically grabbed it from his notes because partly in interest of time, we're not going to cover every method. I mean, even as a developer, you don't necessarily know the ins and outs of each and every class, just the methods that you use. I include these because he included them, because presumably they might show up on a quiz. Now, I assume he picked these. My guess is because he likes to find the equivalent of Python, probably because of the teaching tool. So teaching and learning to leverage what you know. So I notice all these have an equivalent Python, at least at this point. But if we stick over here, these first two columns, they're actually mostly straightforward. We added an index. Between this, just the description, just the method, its name and its parameter list, it gives us a pretty good idea what it's supposed to do. And if we need to, we look at description, it tells what it does. This is I'm going to take an aside, but an important one. This illustrates the importance of good programming style, having good names that are self-explanatory. I introduced the term, is an example of, can't remember the term right now. I just drew a blank, had it in class this morning. Not self, it's the wrong term I got here. Code essentially, I'll just, without using a term, I'll describe it. Code where it's self-explanatory. Just can't think of the term right now. I had it in this morning's class, where you don't need documentation to explain it. Not self-descriptive, something else. But good style, they're following good style. You can figure out what it does without looking at documentation. Add all. You add a list, basically, add it. Now this looks like he's got, I copy paste out of his, so this looks a little wonky here because there's no index, see, but he said insert all at index. So I'd actually have to, maybe it's at the index at the end. I'd look at the API, but this part comes from him, Professor Hudson's. There's obviously no index. It's a little wonky. I think he probably meant to say end. Clear blows away the list. Does it contain? So you're looking at a data value essentially, not the index. Does it contain a true, for instance? So we'll have some methods to explain it. This is a little bit more complicated. Self-documenting code, that's the term. So if the code is clear enough, you don't actually have to look at documentation. The term is self-documenting, illustrating the importance of good style. Okay. Index of, so if we have a string, if it's all strings, a name, what's the index of it? The first occurrence. We can have duplicates. Remove a particular index at a location. Remove an item. And I'd say because this one, what the heck is it? Index of get first item. I look at the API to be sure, but to be consistent, I think this is probably removing the first instance as well. I would have put that in the explanation myself. Again, out of brevity or quick speed, I copy pasted his, but I'd actually clarify that myself. I think that it should be removing the first instance, be consistent, but to be sure, I'd look at the API. That's the definitive source. Size, we've seen that, how big the list currently is. This part, you have seen some examples where we use helper methods to fill in functionality. For instance, recall with class arrays, we've used that helper method in conjunction with arrays. With an array, because you cannot pass a Java array to print or println and get meaningful output. You get that letter and then at some numeric value. In order to have it basically display sensibly the contents of the array, you pass it two strings. You're using another helper class, and that's what role this plays essentially. But it's not displaying, but it's sorting in order. Class collections. So you've seen how some of these ones work with the code that preceded this. Class collections. A collection is a composite. It's almost like a container, a grouping of individual items. There were, with the history of Java, I recall ones like this, vector. A vector was a collection, and you could store stuff in there and allow you to iterate through it. It wasn't the easiest one to use. I remember that from my student days. And there were other ones like the aforementioned arrays. Each of them worked, but they were separate classes. So how you actually, the methods for doing things were inconsistent. That's the bottom line. It's an inconsistency in how to do things. So class collections is like these ones here. The vectors in a great name, where you have a composite that includes elements and you can access individual elements, but it's a consistent way of accessing that functionality. That's the way I'll describe it. Rationale. Now, this isn't an official Oracle website, but its explanations are actually fairly clear. And I'm tempted potentially to use it under the testing section because I, just before class, I was actually looking at testing for an explanation. He's got some terms, Professor Hudson, for the testing types. And the best explanation I've seen so far for it, because it's pretty abstract in his notes, is this one. But I only just started looking at sources to help you out as an extra source. So it's a pretty good one. It's a commercial one, undoubtedly. So when you go to it, they have ads and they've got other things. They might even be doing what you call data mining there, cryptocurrency data mining, where if you go to the site, it's actually calculating the mining of cryptocurrency. That's speculation. But I noticed my device slows down greatly when I go to that site, even fairly fast ones. If you have a slow machine, it may slow it down significantly. And they have ads and other things. But nonetheless, the Geeks for Geeks is still pretty good in explanations I found so far. Okay, some of the operations. These are fairly straightforward over here. Self-documenting. The shuffle. Well, the sort will sort in ascending order. So the reverse basically sorts in descending order. I surmise from there. The shuffle, he picked this one. So what I can't do, I can explain how it works essentially. That's the description. So you have the existing elements, and it's almost like taking cards in a deck, and you're randomizing the order of the cards, but it's still same cards. You're not changing the data. You're not adding something beyond the 52 suits. Now I can explain how it works. Why use it? Why I picked it? Don't know. But he picked it, so presumably it's one of the ones, maybe it shows up in one of the assignments that I'm not aware of. This one's another kind of wacky one. Replace all. The definitive explanation for how it works is Oracle, because Oracle basically is behind Java. Replaces all occurrences one value with another. So the way it sounds like what you're doing is you've got your array, your composite, and you take this one, replace this one, which sounds a lot like the shuffle as well too. So I'd have to really look at the API very closely, because this explanation really sounds a lot like that explanation. Although it might specify, no, it's a specified value in the list with another. So for a while, I thought maybe it added a random value and was changing it. But that's not what the docs appear to be saying. Hash set, another class. I don't like this name as much. One, because you think two things. One, hashing, and then you think of sets, the Python set. Which is it? Is it hashing or sets? If you call there's hashing, there's a dictionary in Python where the key versus the data, it uses some hashing algorithm so you can retrieve them very quickly. Professor Zal's notes went into great depth how quick it was, but the main thing is it just has some sort of key that it associates with this. Writing a hashing algorithm is something that you do in second year, but the idea of hashing is you were introduced to. Fine. It in some first part makes me think that it involves hashing, but it's basically involving sets. A rather long explanation, but hopefully the bottom line part, just look at the second part of it. Sets, and now that it's sets rather than hashing, it's kind of like Python set class, except it doesn't have the set operations. Sets about set operations. There's other classes that have some set operations as well too, but in his opinion, he counted as the closest. And he was really, really strict on picking ones that matched up only with Python. Here's the operations here. Add an item. So you don't have to add a location because set theory, each element has to be unique. No duplicates. So that extra little explanation from, I think that's Professor Hudson's. Blow away the set. Does it contain in that population? Remove that item. We don't have to specify an index. It's not the first one because there's only one. So it's a little bit clearer in some of the other ones. Set the size. So we can predetermine the population size essentially. And then we have over here the Python equivalent for these operations. The course is more on Java. This is more just a learning bridge in case you don't understand this. Usage examples. So we create a hash set, basically. And it's non-homogeneous the way I've created it here. So just for the heck of it, I had different types: string, integer, Boolean. Print it out. Now, I said that in Java, now I can give you an explanation here. The parent of all classes is class object. And I said that when you pass a class that you define, say I define class person, class foo or something, it automatically is a child. It extends all the capabilities of class object. Class object has a toString method implemented. So when you actually pass a reference to an object, even if you haven't written a toString method, it calls class objects toString. And if you look at class objects toString, why does it return a hash code? How did I find out that it wasn't because I looked at the Java API definition. You can override it, and that's what they've done here. So in this case, they display the data. So now previously, last week, I said, when you have a reference, the intro to OO, and you pass that reference to toString, you get a hash code. I said, if you know how, you can actually prove it to yourself, look it up. Now you know where to look it up. Look in class objects toString method, and you see I'm right. This one has actually written its own version of toString. How is toString called? It's implicitly called. If you pass a reference to an object, it calls toString. It's one of the ones like the underscore in Python, automatically called. Although you can actually call it this way. The shortcut is so you don't have to say reference name dot toString and do it that way. That's how it's implemented in Java. And there's an equivalent in Python that we never did talk about. Underscore str. Okay, the contains, well, we add 7 here, so it returns true. Does it contain true? Well, we add a Boolean value, so it's true that it contains true. We remove 5 and 7. Well, there's different ways of handling this. The 7 is easy because 7 exists. With the 5, some classes will actually throw a runtime error. In this case, it checks to see it doesn't exist, and it doesn't do anything. But it removed the 7, so we still have the alpha and the true here. But it shows in this case it's actually doing a deletion. Time. Okay. Overboard. Okay, so I said at this point, here's how we can create a hash set, and it's heterogeneous. Elements in this population aren't all the same type. If we want to constrain it and say this hash set only contains certain types, that's how we can do it. And here's essentially how we can kind of get the implementation of the primitives if we want to have numeric values, because you can actually convert between a class integer object and the primitives. So we say now it can only consist of integers with the angled brackets. We need it here and here. That's fine. This results in a syntax error because we're trying to, the error says we're trying to convert a string to an integer. And that's a copy paste. Well, that's literally a copy paste of it. Iterating the hash set, we need to actually have it constrained because we have to specify the type of each element. Now, in this case, because the elements can be actual simple types, we might have a problem here saying it's class object because the simple types aren't a class, so they aren't derived from class object. I'm not sure if that trick works with the other ones. It just occurred to me in that class, so I never tested it in lecture this morning. Hash map. Now, this is the one that involves the hashing Python dictionary. Key and data lookup value. You can specify most anything. So I picked a rather wonky type. You say, well, why would we actually have this for a value? 2 reasons. 1, just for the heck of it, to show that you can pick anything, even if it doesn't necessarily make sense. 2, I picked it. It's actually scanner, class scanner for the value, because it's one that you've instantiated. The summary table, as before, I got from Professor Hudson's notes, so you don't miss anything. Most of these are pretty clear, blows it all away, checks to see the key. So the key could be, for instance, say in dictionary, if we had dictionary with, the key was for student files, the key could be your student ID number, and then your value could be an object, class student, and it looks up information about a student. Contains key, so what we're doing is, with the student database, we're looking up, do we have a student with an ID number or an employee with a certain SIN number? Contain value. Now we're actually, if we had a string, that's easier to see. Say if we have just a string for a student, so it's easy to visualize, does it contain this particular name? This one can be tricky if we have duplicate values. Even if it's a composite field, students where you have name, address, well, we could have actually 2 students with the same name and same address, for instance, not all, say a parent and a child. Entry set. So this gets basically the whole dictionary, the key and the values, as we'll see. This gets the keys, the ID numbers, put, so we can put a value at a location. Say the key is for student ID, student records. We could say, give a student ID number and then update the student information. They've moved, they've been married, or change your name, for instance. There's an example of how we use it. The get, so we give a student ID number as an example, it retrieves the student record. To remove, we delete the student record. Maybe the person was erroneously added as a student. We get rid of them from our database or dictionary in this case. The value, so this one retrieves both the key and the value. This only retrieves the value. So we retrieve the student records without the student ID numbers in this case, as an example. Some examples of how this works with these methods. So I create a hash map of particular size. I have a name constant here. I try and display the keys. If it was a student record one, the student ID numbers, the value, student information. I created it, but it's empty. So it has two empty sets, two empty square brackets. Now, these could be student ID numbers. The first student, I kept it simple, strings here. We print out the keys and the values here again, and now we get these separate. Fine. We get the information, we retrieve the information from one student, 676, just the data value. We show the whole hash map here. Now, what am I doing? In this case, I pass this hash map and I called key set or key values. But if I pass the whole hash set to it, undoubtedly it's got toString implemented. And toString, it has a method like this. That toString is implemented such that it actually nicely displays this rather than having them separate. If it's a big database, then it's hard to see which is which. But here it matches up, say student ID, student. Notice it's not in order. Nope, it's not in order in which we add it. Just like with Java, Python dictionaries, it adds it based on its own internal efficiencies. This is the best way it's determined as we're creating the hash map, almost certainly. Okay. Does it have key of 666? In other words, do we have such a student ID number? True, false, false. 676. Yes, we do. We added one right here. Contains value. So we check to see student records. Do we have this information for a student record? Yes, we do. It returned true. And this is one where I think contains value. Oh, I might have goofed here. Looks like I actually reduplicated it twice. Oh, no. Wait. Sleepy. I said that this morning. I'm wrong. I tricked myself over here. Small thing. Details, it's case sensitive. I'm a fool. At least in this morning's lecture, I caught it now. See, case sensitive. First student, lowercase. So first student, lowercase one, it's true. First student, that one character off, it's false. That's it. So how can we specify, what the heck are we doing? During creation, oh, here's how we can specify over here. I had to look at this. I haven't actually used this much. The type of the key, it's all strings, the type of the data. So you can pick most any type here. I picked these two because they're classes that you're familiar with. Any of the Java classes, if the name is known, we might have to import it, or ones that we've actually created ourselves. And that's the second one's actually useful because we could be tracking records for a class that we have customized. And yeah, we would not, at least I cannot think of an example why you'd have multiple scanners, but I did it because it's a familiar class and to show most any class can be used as a data value. Iterating it. So I'm manually putting hash map 1, 2. Oh, so I'm going by the key set over here, putting keys at key 1 and 2. Or put. This is where I'm actually manually put over here. The put is creating it. That name I'm not overly fond. It's kind of almost like a version control system. I would put add or something. So it's actually creating these instances. So I got a little bit wonky for a second. It's creating these ones, adding them to the dictionary, but they call it put for some reason. And now that I've added them, I'm iterating through it. It's a integer key. It's a string for the data value. So I iterate based on the type of the key here. Let's see. So I've already retrieved the key here, so I don't need to have HP get key. The string stores, and then HP get, and then get the data based on the key here. So it returns the data value, alpha. just to be complete, Professor Hudson doesn't have it, but because he sticks so closely with Python, you might ask tuple. What's the Java equivalent of a tuple? It doesn't have a tuple class. If you look it up, however, it does have a tuple interface. But as I quickly mentioned, an interface is not the same as a class. You can't instantiate a tuple in Java, nor so you cannot actually call methods. That's the end of this section here.